recording your episode now.
We're just like jumping right into it. Oh, that's awesome.
Jumping
okay,
right
so
into it.
anyway, no, I don't know.
Yeah, we have to start this episode. This is erase all of what we just talked about. We have a new episode to talk about now, so we have to do a new
Are we
intro.
going to leave this in where we talk about how, like making the sausage? Like we just did an intro for a completely different episode, and now we're like literally seconds later starting the next episode.
We probably won't leave that in.
You don't want to leave that?
No.
Well, we got to tell our Patreon listeners. And Patreon listeners are Paul. Should we name them all?
Well, have we started the show yet?
Yeah.
Okay.
But I don't know if we should name them all because, like, we already did. And
here's what we'll do. We will be sure to list all of our Patreon supporters in our show notes.
Okay.
Every other week.
Every other episode or every other week?
Every other episode, which is every other week.
Yeah. No.
So
it's not. Every other episode is every 4 weeks.
Oh, every other week then. What did I say?
You said every other week, and then I asked if you meant every other episode or every other week.
Why the hell would I mean every other episode?
I have no idea. I was just trying to clarify.
No, every other week we will be sure to list our Patreon supporters in our show notes. So go check out your shout out there. General shout out to everyone supporting us on Patreon. We could not be doing this We could not be doing this without you. Thank you so much for participating and supporting us.
Yeah.
I guess I should say that this is Culture Just Weird. This is Chris and Kayla.
Thanks.
We didn't do that for the other one.
Oh, for the last episode?
You want to just record this Chris and
Are you going to be able
to
cut this all together?
Yeah.
All right. This is Chris.
And this is Kayla.
And this is going to be...
Cult?
Or Just Weird.
That was good. I like that. Do we want to do another one for this episode? Christopher.
Wild and woolly recording session here.
That's you. You're wild and woolly.
That's woolly.
Wild. You're wild. I'm woolly, and this is Culture Just Weird.
No, actually, I think it's the opposite.
I'm wild and you're woolly.
You're wild, and I'm like extremely hirsute.
And this is Culture Just Weird.
This is Culture Just Weird.
Thanks for listening.
Yeah.
I'm sorry that we're punchy today. What do you have for us?
An episode. Actually, I have several episodes.
Okay.
A topic. Several. I believe it's going to be 2.
That's a couple.
I don't know. It feels now like our listeners are going to be like, wow, they don't even know how many episodes it's going to be. But that's fine. I guess just, again, you're seeing how the sausage is made here.
We go with the flow.
We go with however many episodes it takes to tell a good story.
Yep.
Or a mediocre story in our case.
Yep.
So no business for this one? No banter? No nothing? Just jumping right in?
I don't have any business. Do you?
Not really?
Oh, except... okay, I won't name names, but one of my favorite podcasts just changed their name and host.
Is that why you won't name it? Because it's changed?
And I'm very sad about it.
Wait, why won't you name names?
Because I don't want to blow up their spot. I don't want to...
Blow up their spot?
Yeah, I don't want to...
You don't want to explode their dog? Is it like, what does blow up their spot mean?
I don't want to make other people mad at them, or I don't want to like call them out. I just want to... I just want to bitch.
Well, if you don't want to call people out, this is not going to be a good episode for you.
Oh, God.
Because this one sort of names names.
Well, I mean, I feel like if you're doing it, then that means it's warranted.
Right. Well, yeah, I'm sort of a...
Is this the episode that you were like... There was a while back where you were really kind of destabilized and fucked up. Was it
actually,
from this?
Yes. Well, it's this topic. Yes. So, so I was going to say, actually, it's not necessarily business because it's related to the topic at hand, but this is one we've sort of, I've teased at a couple times, like, I'm working on this one, and it's just been like forever, and we're finally getting it out to you. So stay strapped in. You'll understand next episode why it, took a little bit longer. But yeah, it did destabilize me, and actually that's sort of, next episode will be part of what we talk about, because my journey through this story, I felt was like part of the story. Gotcha.
Interesting.
So,
I like that. Very NPR.
Yeah, I learned from the best. Thanks, Ira Glass. Anyway, today though, how do you think I'm going to start the episode?
You're going to ask me a question.
Oh, see, now what we've done here is we've established this pattern that people are comfortable with now. Right. It's like a sitcom. It doesn't even matter if it's good. You just want to come back to it every week because it's familiar.
Well, here's the problem, though. I don't have a pattern.
Yeah, you're fucking up.
Yeah.
Yeah, I don't know what. No, you have a pattern. Yours are like super long.
Fuck you. My last two episodes were an hour. I did good on my last 2 episodes.
You did. No. I'm just making fun of you.
Yeah, I know.
And besides, like, one of your longest ones was Cicada, and that was one of your best.
Yeah.
One of the show's best.
Oh, yeah.
I
Probably
might
the
say.
best.
Yes, but mainly thanks to all of the Cicada researchers that helped us out.
Yeah.
Only if they're still listening, though. If they're not still listening, I don't care. So...
Thank you, Cicada Solvers. And now what's this topic? Who should I thank
It's
here?
not that at all.
Okay.
Well, actually, you could thank someone. I won't name names, but this was a listener suggestion.
Ooh.
And I'm saying that, 1, because it's super cool, and 2, because I just want to throw out there that we do take your suggestions to heart. And
I'm assuming that this listener just did not want to be... This listener submitted anonymously?
they didn't say one way or the other. I'm just being cautious and safe. Like, there's nothing like crazy, like controversial about the topic, really. But I just safe than sorry.
Right.
Because then I have to go back and edit stuff, and then I don't have to email the person and be like, "Oh, do you want to be known?" And then I have to edit it out. It's safer just to be like, a listener told us this. So, Kayla.
Yeah.
Tell me, what do you think is the most amazing thing in the universe?
How many things are there? Okay. It's potentially the potential number 1 for the top spot. Is that question, how many things are there? It is the greatest question of all time ever posed. How many things are there?
I don't. But has anyone posed that, or was that just in your head? I thought you weren't able to find the.
Came from something. I don't think I came up with that. That came from something. It was like a Quora question or something.
Yes. No. You've been asking that before Quora was ever a thing.
How many things are there? I didn't come up with that. The most amazing thing in the universe. I'm still pretty mind blown by learning about Laniakea, or like interstellar cluster, or whatever it's called.
Yeah.
The like cluster of galaxies that the Milky Way is a part of.
Yeah. So what is it? It's the it's not a supercluster. It's like a different thing. No, it's much bigger than a supercluster, I think. Well, I could be wrong.
Duper cluster.
Hold on, I'm looking it up. There's a Laniakea beach somewhere. Oh yeah, you're right. It is a supercluster.
Well, anyway, I am pretty impressed by the Laniakea supercluster, especially because we watched that YouTube video that translated Laniakea into immeasurable heaven, which still like makes me verklempt.
I think that you mostly like it because of the name.
No, the actual thing itself is pretty fucking cool.
I know. I'm just saying.
But also, the most amazing thing in the universe is probably black holes.
Right. Yeah. Actually, so I have a note here that was like, "Yeah, you're probably right. It's probably black holes," because I just assumed you were going to say black holes.
Really?
Well, yeah. And like, it's probably true.
Listeners, I guess full disclosure, like 95% of the reason we're even like together as a relationship is because of black holes.
Yeah, I would say that's 95% true, and then the other 5% is just, I thought you were hot.
Yeah, but it's mostly, we both talked about black holes.
Right.
What do you think is the most amazing thing?
It's probably
black
holes are pretty freaking nuts.
Yeah.
In terms of like mind-blowing, like bizarreness, I don't think you can beat black holes.
Right.
But for amazingness,
although atoms are pretty fucking amazing.
Pound for pound, yes, they are. But they're also just like, it's just because they're like small, you know? There's nothing too crazy about like a hydrogen atom.
I don't know. I think they're pretty crazy.
Pound for pound for me, amazingness might actually be DNA.
Yeah, that's also a really good choice.
Because it's not just DNA, of course. It's like all of the, and I guess it's sort of like a cheating answer to give, because I also mean all the chemistry involved in making life work via the processing of DNA and whatnot. It's really, truly incredible.
Is consciousness a cult? Is passing on our genes a cult?
Is everything a cult? Oh,
potentially.
Great. We have infinite content to work with now. That's great. So as we mentioned, today's topic is going to be a two-parter, much like when we did our MLM primer, followed by a discussion of Mary Kay. This first episode is going to be a primer on the topic, and next episode we'll talk about the actual cult or just weird.
Okay.
There's also another similarity with the Mary Kay episode that I'm very excited about, and it rhymes with Binterview.
Ooh.
Mm-hmm. So, yeah, and ooh is right. Yeah. It's a cool. I won't get into it now because we'll get into it next episode.
Okay,
exactly what it is. So before I get started telling you a fun science story,
Ooh.
I want to do our ritual of citing sources so that you know whether to trust any of the rest of anything I say.
Gotcha.
And this one is like kind of long. I think a lot of it is just because over like the last, N months, whatever, 3 or 4 months, I've just like accumulated stuff just slowly.
Right.
But some of it is that it's a very it's a complicated topic,
okay.
and I think part of it is that sort of like journey of disorientation I went on. And anyway, here are my sources. Wikipedia as the warm up, as always, of course. I watched a whole series of YouTube videos produced by a genetic counselor.
Wait, have you told us what the topic is?
No.
Okay.
No, I might not even tell you.
Is it DNA?
Is DNA a cult? No, but I will tell you. I promise to tell the topic before we go to episode 2.
Okay.
But remember that this. Well, I mean, we didn't say Mary Kay in the MLM episode.
True.
This is a primer.
Okay.
I'm going to tell you about this science stuff.
Let's do it.
And then we're going to go into the actual like group, cult, whatever.
Got it.
Anyway, so I also watched several videos, which I can't really spoil here because you just asked if I'm going to tell you the topic. I'm not going to tell you here.
Damn it.
But they were videos of the charismatic leader. I read part of a book called, quote, Super Genes.
What are those?
We'll get to that. I read some stuff from the Mayo Clinic, an article on Gizmodo, an article on Forbes. I spoke with one of our listeners about this. Actually, the one that recommended the topic had a wealth of information for me.
Nice.
A website called Skeptical Raptor.
I'm sorry, what?
Skeptical Raptor, which is actually, it turns out, is like a pretty cool website.
Well, it's a bitchin' name.
It is a bitchin' name. I think the reason it's Skeptical Raptor is because like the slogan is stalking the jungle of the internet for like untrue. I don't know. I'll look it up. Hold on.
Is it because velociraptors, we should be skeptical of how they're portrayed in Jurassic Park? Because that's true.
Yeah, I mean, they should have feathers.
They should have feathers, and they probably were a lot smaller.
Okay, stalking pseudoscience in the internet jungle is their slogan.
Yeah.
Yeah, it's pretty tight.
That's like my brand.
I know. A website called sciencebasedmedicine.org.
Hell yeah.
Also very good, and will pop up in our conversation later, definitely next episode.
Ooh.
I also read up some articles in a National Geographic magazine, a physical magazine.
Wait, where did you get a physical magazine?
That I picked up from the grocery store.
What?
Because I saw it, I was like, oh, wait, that's the topic I'm looking at. That's awesome. So I bought it and read a physical magazine with like real pages and everything. Those still exist.
What?
I shit you not.
I don't know what's happening right now. I'm very confused.
It's real. I also had a lengthy interview with someone by the name of Alex, who is the sibling of one of our friends and Patreon supporters.
Shit!
Yeah, she is a
I know
like
who
a
this
senior
person
research
is. Yeah,
fellow.
sorry.
Yeah, we've met her and spoken with her in real life, and she's like super smart. And she's a genetic researcher at a private like research organization. But she, I'll go into it a little bit. But she has like a lot of schooling behind her.
Right,
too.
right.
Like so I spoke with her for quite some time, and she had a lot of good insight. And then I also spoke with, not on the phone, but on chat, with a former genetic researcher at Johns Hopkins.
Shit.
And that's someone I worked with on the BI team at Blizzard, actually. So, so this one's been in the works for a while. We've teased it multiple times on the show, and that's, again, part of why I've accumulated so many sources.
Sure.
And I'm also a little bit out of my element for this topic. Like, I kind of knew more what I was... I probably could have given that whole double slit experiment talk, like, roughly without any research, but this one definitely not. So I felt like I had to consult a lot of expertise.
As you should.
And as we mentioned, my own personal trust network got a little bit ruffled during the course of the research.
Wait, what does that mean?
Well, it means I got a little disoriented. We already talked about that. And there's actually one more source that we will be consulting in the future, which again rhymes with Binterview. So I'll cite that maybe next episode, since that's what next episode's about.
All right.
Anyway, the way I'm going to prime the pump on this topic is very similar, actually, I just mentioned, to how we did for the episode on Ramtha and What the Bleep. we're going to start by telling you another science story. And I'll try to make as much sense of my explanation as I did with the quantum double slit experiment, by obviously which I mean no sense at all. By the way, this won't be the last callback we make to that episode, since there are some striking similarities between Ramtha and What the Bleep and the topic we're talking about today.
Jesus Christ.
But the very first similarity, of course, is right now, which is we are starting with a science journey. Are you ready for this journey?
No.
Okay.
I mean, okay, I'm ready, but I am not prepared.
No, it's amazing. So take a deep breath, close your eyes, and imagine yourself in a room. And I myself am laying down on a table next to you.
I'm already out.
In front of you is the suit from the Ant-Man movie. Paul Rudd is nowhere to be seen, so you being curious, you obviously don the suit, and suddenly you begin shrinking and shrinking. You continue shrinking more and more until you are all the way down to the size of a human pore, so you can jump into my arm. And that's going to be about 50 microns, give or take. And a micron is simply 1/millionth of a meter.
That's very small.
Yes, so it's 1,000th of a millimeter. It's quite tiny, and about 50 of those makes a human pore. So you're about that size, and you can go through. And as you keep shrinking and hop into my arm, you keep shrinking down until you're the size of one of my cells. Cells are about, give or take, depending on the cell. They're wildly different sizes, but let's on average say they're about 100 microns in diameter.
Okay.
Which you'll note is bigger than a pore.
Yeah.
But if you're only the size of the pore, you're half the size of a cell already. So you need to shrink down a little bit more to actually go swim around inside the cell. But like I said, I thought it was kind of interesting. The smallest cell, I believe, is based on my research, is actually a sperm cell.
Ew.
And those can only be up to 3-4 microns in diameter.
Okay.
And then as high as 120-ish microns for an egg cell. And that's, I think, the largest human cell is an egg cell.
Yes. And
egg cells you potentially can actually see unaided with the human eye. You can see it without a microscope.
Ew,
they're so large.
What?
It's possible to see them.
Oh my God.
I think so. At least that's what I read. I don't know. I read it a couple places, so I think that's right. And even though that's the sort of the smallest and the biggest, that's just talking about generally speaking,
Sure.
There are some cells that, even though they aren't as volumetrically as big as an egg cell, they can get pretty large. So some neurons, even though they're only a few microns around, they can extend all the way into your limbs. So some of your nerve cells are actually feet long.
Right. There's one isn't there one at the base of your spine that's super duper long?
I know there's a nerve at the base of your spine.
It's a nerve cell.
Is there a single? Yeah. So probably. I didn't look it up. I'm not sure, but let's
Why
say
didn't
yes.
you look
I don't know.
up in
You're
the
saying
past
isn't
the
there
question that I was going to ask now?
You're welcome to look it up right now.
Just saying. You should have already known I was going to ask that.
Anyway, back to you in the Ant-Man suit. So let's say you're swimming around until you find a suitable cell to take a peek into.
Okay.
What you're about to see is, as we talked about in the intro, in my opinion, one of the top 3 most amazing things that happen in our entire universe, right up there with black holes and Taco Tuesday.
Right.
Inside this cell and every other cell inside me and you, right now, biochemical processes happen that are so elaborate and complex, but so vital to our continued living, it's kind of insane that they happen at all.
Right.
And yet they do all the time, constantly. And they're happening inside you and me right now, as I said, inside to all of anyone listening to this podcast right now, this is happening in you right now. Once you've entered this example cell through its cell membrane, you are swimming in what's called the cytoplasm of the cell. So that's think of it as just the liquid inside of your cell. It's mostly water. Things work a little bit differently down at the scale. Everything is very jittery because of something called Brownian motion. So it's not quite just swimming around in water. It's water actually becomes very viscous at the scale and things are kind of jittering around a lot.
Gross.
But don't worry about that. Just at this point, you can just kind of pretend like you're swimming through a regular old swimming pool. Your destination is in sight just ahead, which is the cell's nucleus. The nucleus of the cell is porous, which you'll understand why in a minute. But it's convenient now because you can just swim right through one of these pores and get inside the nucleus. And that's where, inside the nucleus, lives the molecules that have essentially become synonymous with life itself, since as far as we know, all living cells use it as the information and control mechanisms for their life-sustaining processes. And that's deoxyribonucleic acid, or DNA. Any questions so far?
No.
Okay. So everybody knows DNA. It's that, whenever you have a biology textbook or anything that has to do with genes or anything you learn like that, or anything that's in a video game or a movie.
When you start learning about DNA in
you see
seventh
that
grade,
double spiral. Yeah.
You watch Jurassic Park.
Right.
It's right there.
Right.
Dinosaurs.
Good job, because we need to mention Jurassic Park in every episode.
It's the only thing I care about.
Actually, we've mentioned it twice now because of Skeptical Raptor.
Yeah.
I guess. So, through line, Jurassic Park.
I'm basically the Jerry Seinfeld of Jurassic Park.
Except instead of Superman, it's Jurassic Park.
Yeah.
Right. Anyway, DNA is super fascinating, and I'm trying to keep this episode a reasonable length. So this whole discussion is just barely scratching the surface on the biochemistry of DNA and that whole story. So for the purpose of this podcast, just think of DNA as essentially as a blueprint. But don't think of DNA as a blueprint of how your actual body looks, right? There's no drawing of Kayla's body on some blueprint living in your cells. It's not a blueprint for that. Why not? Well, because that's just not how it works. In a complexity sense, it can't really work that way. But again, I can't get too deep into some of these details of how this stuff is. But the point is, it's not a blueprint of how your body looks or how it's put together. DNA influences all that, but it doesn't specify exactly how it's supposed to look in its code.
Right.
It's actually a blueprint for proteins. So yes, our cell nuclei are fucking swole, bro, and they don't forget leg day.
They love protein.
They love protein. But let's talk about proteins and why they are critical for life. Protein is basically a catch-all term for a specific type of complex molecule that's made up of chains of other special molecules called amino acids, which you can think of as the Legos of proteins.
I will think of them like that from now on. Thank you.
Yeah. So you've got atoms which make up molecules, and some of those molecules make up structures called amino acids. And these amino acids, chained together, make a protein. Now, depending on which amino acids are used and in what order, that makes a different protein. So some proteins will have different amino acids in one order, and they'll have a different protein as different amino acids in a different order, or maybe the same amino acids in a different order. But that's all proteins are, is just long chains of these things that all just ended up getting folded up based on what amino acids were used in the chain.
Okay.
Does all that make sense so far? Mm-hmm. What proteins are and how they're built?
Yes.
Okay. And so we just talked about how proteins in different orders fold differently, and that's actually a crucial molecular habit that these proteins have of folding all around in very specific ways, because that's what makes them do what they do. Use one combination of amino acid chain and the protein folds into one weird shape. Use a different combination, it folds into a different weird shape. And then depending on how they folded, they have a different function within your body, within the cell.
What's the they?
Proteins.
Okay.
So proteins, again, just to recap, they're made of amino acids, and then depending on which amino acids you use and in what order, it causes the final structure of the protein to fold in different ways. So folded proteins are essentially the tool molecules for life. They guide chemical reactions. They bind to other pieces and bits of your cells, or to other proteins, or to invading cells, or whatever. They're just all the little tiny tools floating around in your body, in your cells, in your bloodstream, and everything, and not just you, not just humans, but everything. And the shape of the fold determines their job. So if proteins are like your toolbox, then folding a protein one way makes it a hammer, and folding it a different way makes it a screwdriver. Folding it another way makes it a wrench. So you, at your shrunken Ant-Man level, you would see all sorts of these proteins floating around the cell cytoplasm doing various jobs.
Gotcha.
And there's a whole fuck ton of proteins that do an equal fuck ton of things in your body. Like I said, some of them are responsible for one chemical being converted into another that's needed for your body. Some of them are responsible for digestion. Some of them are responsible for releasing energy for your cells to use. But you have thousands and thousands of different types, and they're all doing all these different things. Do you want to guess how many different types of proteins you have floating around in your body?
100,000.
Good guess. I figured you would probably overguess by the way that I asked that question, but it's 20,000. You have 20,000.
Oh, I thought it was me way off.
Like off over or off under?
Off under.
Oh, really? No,
Yeah.
I guess then the answer is only 20,000. Isn't that crazy?
20,000 is insane. But it's just like...
I guess for all the different things that we're talking about having them do, yeah.
It's a lot. There's when we're talking about this shit, there's not that much difference between 20,000 and 100,000. Like, it's a shit ton.
Right. Yeah, the answer is shit ton. So you might be asking yourself at this point, how do you even get these proteins in the first place? Or I guess, how do you put these amino acids together? Where do they come from?
You take a protein powder and then you mix it into your almond milk and you shake it up.
That's right. That's exactly right. Yeah, you got it. And then you go drink a couple of raw eggs.
Yeah.
And then
you crack them directly into your mouth.
I mean, that's not wrong. Like, that is how you get the raw materials to build these proteins. But I guess the question is more, once you've broken down these raw materials, how does your body turn them into the proteins that it needs?
Right.
Not just egg whites.
Right.
How do your cells, quote, know how to put proteins together, 20,000 different potential kinds, together to fold up in these crazy specific ways to do crazy specific things? This brings us back to the thing that you shrunk down to come look at in the first place.
Why did I shrink down and go into your cells?
Because you're weird. B, you're curious. C, if you have an Ant-Man suit, come on.
You're immediately going to jump into the body of Christopher Carlson?
If that's the body that is lying next to you right there. But if it was a different body, you would probably do the same. You would totally, go all inner space.
Feels very violating. Do you have consent?
No, you don't need consent at that scale.
I feel like you do.
I don't know. None of my bacteria gets any consent except for the stuff in my kefir.
Yeah, but maybe it would be nice if they asked for consent, right?
If the bacteria asked for consent, I guess then we wouldn't need immune systems. That'd be nice.
Or a virus, if it had to go excuse me, knock knock, may I? And you go, not today.
Right, but then all of the parasitic organisms and all those diseases, they wouldn't be able to exist anymore because everybody would just say no.
I'm fine with that.
Those poor diseases.
I'm okay with that.
Did you get their consent to not exist anymore?
If something requires you to exist, it's kind of not your problem.
Well, this sounds like a bit of a bigger discussion because some parasitic relationships evolve into mutually beneficial.
Like them fish that hang on the shark?
Symbiosis relationships? No, I don't think those are just pure parasitic. You talking about lampreys?
No, the ones that swim along with them.
Oh, and eat the parasites.
Yeah.
Yes, but they themselves are not parasites.
No, but it's like a symbiotic situation.
Yes, it is. Anyway, consent or no, you wanted to jump in and see what DNA looked like. You totally did, because that's required for my story.
Okay.
So yeah, you wanted to go in and look at the DNA, which, as I mentioned, is literally a blueprint for the construction of these vital proteins. So think of your cell nucleus as like a bank of critical information, and the DNA is the vault safe in the bank. It's a very stable molecule, very, very long molecule that can be called upon when needed, quote unquote needed, to release its information to the cell in order to create a needed protein.
Can you say that again? I didn't understand it.
Okay.
Sorry.
No, that's okay. So your cell nucleus is like a bank of critical information, and DNA is like the vault safe in the bank.
Okay.
It's like the blueprints in the vault safe.
Okay.
And it's a very stable molecule, which is part of why the information gets stored there, is because if you need information to blast from birth to death and then also to be passed on to, your next generation of kin and whatnot, you can't have that information being messed with or disordered or whatever. Not to say that it doesn't, but if you have that happen too much, then it's lost all value as a store of information.
Okay.
So you kind of get what I'm saying about the DNA as the blueprints in the vault?
Yes.
Okay. So when a particular protein is needed, quote unquote, the cell nucleus undergoes some chemical processes that basically We'll talk about this in a second, but they'll basically unwind the DNA at a certain point and then read that information and then pass it to other mechanisms in the cell. So remember I was just saying it's also very long.
Yeah.
Do you want to guess how long an individual DNA strand is?
I used to know this. I don't remember anymore. It's insane.
So this part is like the mind-blowing thing.
Yeah. It's truly insane.
That I've been wanting to, like, remember I was saying the other day, like, oh, I have a mind-blowing fact for you.
Tell me.
So if you were to stretch out a DNA strand, an individual DNA strand, end to end, it's longer than you are tall. It's 2 meters long.
That's so fucked up.
Roughly.
That's so fucked up.
All packed into, not just into a cell, but into a tiny nucleus within that tiny cell.
Right.
All wound around.
It's insane.
Do you want your mind blown even further?
Yes.
So I ran into this cool stat that I wanted to fact check because it blew my mind. And then, like, based on the numbers I looked up, I actually made my own little version of the stat that I think is maybe a cooler way of saying it. So let's say you started unraveling all of the DNA in all of your cells, all of them.
I don't want to do that.
Well, you're doing
Seems like a bad idea.
All right, well, then you don't do it, and we move on to the next part of the episode.
No, I'm just scared. Tell me.
Okay, and you have infinite time because it's going to take a while.
Right.
But let's say you started unraveling all of your DNA in all of your cells, laying them end to end. How far would it unravel? I'll give you a multiple choice answer. A, around the Earth once. B, around the Earth 20 times. C, until you went from the Earth to Mars. Or D, until you went from the Earth to Neptune.
Around the Earth twice.
That was not an answer.
Wait, yes it was?
It was around the Earth once, or then the next one was 20 times.
Oh, well, I pick around the Earth twice. No, around the Earth 20 times.
Okay. I'm going to say it's not that.
Okay, so tell me what it is.
I want you to guess again.
I don't want to do that. Just tell me what
too
it
bad.
is. Well, I'm not doing it.
It's my episode, so all right, packing up.
Is it around the Earth
Okay,
once?
guess again.
Is
Nope. It's not around the Earth twice or once.
I said 20.
Oh, 20. So it's not 20, or I'll tell you it's not once either.
Right.
Okay.
So then is it from here to Neptune?
Close.
From here to Mars?
No. It was actually a trick question.
Well, that's not very fair.
Because it's none of those. By the time you unraveled enough DNA to arrive at Neptune from Earth, you would be 1/12 of the way finished unraveling.
Wait, I'm sorry. Say that again.
By the time you unraveled enough DNA to arrive at Neptune from Earth, you would be 1/12 of the way finished unraveling. You would have only unraveled about 8%
That's insane.
of your DNA by the time you got to fucking Neptune.
That's truly bananas.
Neptune.
That's bananas.
And trust me, I did the math. It checks out because I had a couple times I was like,
You're like, I don't believe this.
no. Because just knowing how vast space is.
Right. No, from here to Neptune is it's an unfathomable
I just found
distance.
that bonkers. Yeah. Well,
No,
yeah.
that's-
Light would take a little over 4 hours to reach Neptune from Earth.
Jesus.
So if you multiply out that 1/12 and do all that math, your DNA fully unraveled is 2 light days long.
Damn.
It would take light 2 days to travel from one end of all of your DNA laid out in a line to another.
Jesus Christ.
2 days.
That's pretty baller.
Yeah, it's
And
insane.
bonkers and bananas and whatever other B word.
Right, it's all the B words. In any case, the point is your DNA, compared to the volume that it occupies, is really, 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 really long. Because again, 2 light days long, but like it all fits inside your cell nuclei.
Right.
And the way it fits into your nucleus is that it just coils up, and then it coils up again, and it coils up again and again. So it's like sort of like if you've ever spun around like a cord or a rope into a coil, and then once it gets fully like into the spiral, it starts like coiling on itself again. Have you ever done that?
Yeah.
Have you ever done that? The original example I was going to give was doing that with like a landline phone.
Oh, yeah.
But then I realized like probably like 80% of our listeners would be like, what the hell's that?
I don't
and they
think
would
we
not be
have-
able to relate to that.
I don't think there's a bunch of Zennials listening to our podcast.
You don't think so?
No.
Or like younger millennials?
I think younger millennials will still be able to understand
So you think
the
it's a bunch of old
concept.
people listening to our podcast?
I think that you just used a word that I didn't use, so
So that's a yes.
no.
In any case, I don't know how many people listening have experience with a landline phone, but I'm sure that everybody's like spun a rope around. Anyway, so all of these coils upon coils upon coils of your DNA wrap around little tiny like lumps of molecules called histones. And histones are, again, they're just like, think of it as like, instead of just spinning your rope around, you're actually like you're coiling it and coiling it and coiling it and then wrapping it around
Right.
like a little rock or something. And somehow all this shit stays organized and doesn't tangle up in your nucleus, which is crazy because like I can barely keep my phone charger cord from tangling with my nightstand lamp cord in the space of my giant boxy nightstand.
I literally cannot keep my wires from getting tangled no matter what I do.
Yeah. And yet our cells have 2 meters worth of DNA strands in their tiny nuclei that are thousands and thousands of times smaller than my nightstand. And they do it just fine. I don't know how they do it. It's insane. Oh, and also they have to coil and uncoil all of the time, constantly. So it's not like, once a day I'm like, God damn it, my stupid phone charger. Like they're just coiling and uncoiling all the time.
Right.
All the time. And if I get my phone charger tangled up, I just get frustrated. But if DNA got tangled up, we'd all be dead.
True.
So DNA is just fucking amazing all by itself.
Wait, does it ever get tangled up?
Probably. I don't know. I'm sure it does. I'm sure there's probably some...
I wonder what happens.
That'll be in our supplemental material. But as I just mentioned, it's coiling and uncoiling itself all the time. And also zipping and unzipping all the time.
Right. I remember the zipping.
So if DNA, if you recall, is like a twisted ladder, right? It's a double helix, which means that it has like 2 ladder sides and then like rungs in between it. And it needs to unzip itself along a length of it to essentially to expose the information that it contains in that length to the rest of your cell. That's why it has to unzip.
Gotcha.
So this brings us back to what we said about DNA being a blueprint. So unzipping it deploys that blueprint information when it's needed to the cell's protein-making machines. DNA along its enormous length has many sections called genes. And that's where the word genes comes from. It's a section of DNA.
Oh.
And these genes are what carry the information on how to build a particular protein. So one gene will be coding for a particular protein. A different gene will code for a different protein. And when a protein is needed, the correct section of DNA will be unwound from its histone. So it's got to unwind first. And then a special enzyme called helicase will unzip the DNA strand along the length of that gene and a little bit more too. Then a courier comes along to read that unzipped DNA section.
I love this guy.
And the courier is called RNA, or specifically messenger RNA.
I love RNA.
Why do you love RNA?
I don't know, man. I just remember liking RNA.
It's like
in
unsung
junior
DNA.
High, maybe. I think maybe we also watched a YouTube video and they like depicted RNA pretty cutely at one point.
Yeah. Well, so it's probably good. I don't think I wrote this down, but so it's probably good here to talk a little bit about like how it's structured. So I talked about the rungs of DNA.
Right.
There are 4 different rung types essentially. There's
ATCG.
8. Yeah. If you've heard of ATCG.
Do we all remember the movie Gattaca? That's where the movie Gattaca gets its title. It's made up of just those 4 letters. It is. That's why it has the title.
I know. So just to talk a little bit about the structure of DNA, the sides of the ladder are essentially structured with like these sort of like sugar substances. That's where I believe where the deoxyribose part comes from.
Okay.
And then the rungs of the ladder, the lungs of the ratter.
The lungs of the ratter
are comprised of what we call nucleotides. The DNA's nucleotides. And
I feel like I'm going to be given a quiz after this.
This is, yeah, I know. I'm trying to make this is not 9th grade biology as much as possible. But I find it really interesting. There's 4, and think of the nucleotides as just like it's the letters. It's if the blueprint is written in a language, then the nucleotides are the letters of that language.
Gotcha. That's a good way of putting it.
There's only 4 of them. And they're called cytosine, guanine, adenine, and thymine.
Hell yeah. You got it.
So that's where you get your C, G, A, and T, which, as we know, the whole purpose of having those letters is so that later when we would make the movie Gattaca, it would match up.
Yeah.
Yeah. So, and then each of these has, so each of those 4 things has a pair that it pairs with. So adenine pairs with thiamine, And so A and T go together.
And G and C.
And G and C go together. So cytosine and guanine go together.
I also,
9?
I need to say, I don't believe any of this.
Yeah, it's all total bullshit.
This is all made up.
Yeah, this is what I'm saying, though. This is what I'm saying.
There's absolutely no way this is real.
The fact that this happens is just, like, so fucking mind-blowing. It's like...
It's mind-blowing that it happens, and it's mind-blowing that we've figured it out, and that's why I don't believe it.
Yeah.
I think it's all fake.
It's completely mind-blowing.
I don't actually think it's fake.
So,
it's definitely real.
So anyway, so those are, like, the rungs, and basically what those individual rungs of the ladder do is when it unzips, RNA comes along, and it matches up its own rungs to those rungs and says like, all right, I'm going to construct a length of RNA now that matches this. So think of the RNA coming in and being like a blueprint Xerox.
Okay.
That's all it is. It's zero because you don't want to mess with the original blueprint. It's got to stay there. It's got to stay stable. It's the blueprint. Don't fuck with it.
Right.
But what we can do is we can make a Xerox of that and send that Xerox off to a factory to tell it how to make a protein.
Gotcha.
And so that's what it does when it matches those base pairs. The interesting thing I thought about, like, I don't know, to me this is weird, is that RNA has 3 of the same exact base pair, 3 of the exact same nucleotides, and then like one that works almost the exact same way, but it's different.
Yeah.
So they both have cytosine, guanine, and adenine. But instead of thymine, RNA has uracil. I don't know why, but so DNA has AGCT and RNA has AGCU.
All right. It's got to be a little different.
Yes. Maybe RNA is a rebel because it's pissed because RNA, the theory, by the way, is that RNA used to have DNA's role. Everything used to be RNA.
Oh.
And then when DNA eventually arose in the chemical evolution of life, that it sort of displaced RNA, and now RNA is just the messenger boy.
Oh, RNA, I'm so sorry.
Sorry, RNA.
We love you.
But anyway, so it would basically make a Xerox copy of that section of DNA that unraveled and unzipped. And then that RNA skedaddles out of the nucleus and heads straight towards a protein-making factory inside of your cell. And those are called ribosomes. And I don't know, think of the ribosome as like, it's like a little tape measure case. And instead of a tape measure going into this case, the RNA goes into it, and it's just like it kind of goes in one end and comes out the other end. And as each little nucleotide goes through, or actually, I guess I should say, as each section of the RNA goes through, depending on the nucleotides that are in the ribosome at that particular point in time, that will match to other amino acid binding sites. And it'll say, okay, if it's this, and this nucleotide, then that means it's going to want to attach to this particular amino acid. Mm-hmm. And then that will chain into the one that was there before and the one that comes after until the whole RNA piece goes through and chains together a specific order of amino acids.
Right.
And as you recall, different ordered amino acids in a chain make different proteins.
There we go. Bring it all back around.
How the DNA gets copied to RNA, exits the cell nucleus,
right,
goes into the ribosome, and constructs a needed protein. And then the protein pops out, it folds up in its particular way.
Jesus Christ.
And it's off to do its biological job.
Okay.
Yeah, that's why I say it's like, to me, it really is one of the most amazing things that happens in the entire universe, and it's happening inside of you right now.
Right.
The whole process of DNA storing protein codes, translating it to RNA, and then the RNA zooming out to the ribosome factory to make a protein is so fundamental to how we understand biology to work, from biochemistry to medicine to evolution to genetics, that it's referred to in the scientific community as, quote, the central dogma of molecular biology.
Damn.
By the way, I read something that said like they don't actually like, some people don't like the use of the word dogma because it suggests like
something
belief and yeah,
right.
And so they're like,
fact,
biology is trying to. We already have a problem with that. Like,
right.
Yeah. So I thought it was kind of interesting, but I
Interesting.
also thought I don't know. It's a cool name for something, I think. So yeah, quite possibly the most incredible thing that the universe has yet produced, right here on Earth. Okay, so that was actually kind of a long explanation. Sorry. I hope you found it interesting.
It was educational.
Yeah, but we're not done. So here's the thing, though. Those genes that I talked about, do you remember what I talked about, like what genes are?
Yes. I could not explain it back to you.
Okay. So genes are sections of DNA.
Genes are sections of DNA. I remember that.
And what do? You said there was going to be a quiz.
They do things.
Yeah. Right. Wow.
They have information.
There are sections of DNA that code for specific proteins. So there's a section of DNA, and all of the nucleotides in a particular order get translated out and then onto RNA, and then they go to the little protein factory. So genes are a specific section of DNA that says this is for making this protein.
Gotcha.
So the thing is...
building blocks of life.
Sure, yes.
That's what genes are.
Exactly. More blueprints.
The blueprints of life.
Yeah. So genes, the thing is they are only a tiny, tiny part of an actual DNA strand. So remember we talked about how long the DNA strand was.
Right.
There are long sections of the strand that we just don't quite know what they're for. They may be for nothing. We just don't know. Do you want to know how much of the DNA strand is protein coding genes?
Yes.
I won't even make you guess this time.
Thank you.
1.2%.
What?
1.2% of your DNA is protein coding genes.
Is that a lot or a little?
It's whatever you make of it. It's all in your head. That means
sounds like
that
a little.
90. Yeah, to me it sounded like a little. I mean, that means that like 98.8% of your DNA strand is not coding for proteins. So what the fuck is it doing?
It's losing money like all the rest of the people in the MLM chain.
Exactly. Well, so for a while, the other 98.8% was considered, quote, junk DNA. So like basically it was literally thought to just do nothing. It was just not for anything.
Right.
But now scientists are finding that there's actually a lot going on in these sections that is not related to blueprinting out new proteins. These sections seem to be responsible for a variety of things. One of those things is regulating the actual coding genes. So like when they turn on, how often they turn on.
Oh, that makes
preventing
sense.
them from turning on.
Right.
Making it more likely they'll turn on, that sort of thing.
Okay.
And other things as well. But now that we're discussing the regulation of genes, that segues us one step closer to our cult du jour. Now we get to talk about something called epigenetics.
Okay. So we have not even brushed upon our topic.
No. Not yet.
All right.
I told you this is the setup. We had a whole MLM episode where we talked about MLMs before we talked about the group. So that's what we're doing here.
All right.
And we will definitely take audience feedback. And if they hate this format, then I won't do it no more.
Why would they hate it?
I don't know. They might hate like the fact that like you didn't talk about a cult. You just talked about gene shit. Felt like biology.
They can fuck off.
Yeah, fuck them. That's right. Fuck you, audience. So all the blueprint stuff we've been talking about, all of those blueprints are basically like, think of them as just like hard coded. Like they're just written in stone.
Okay.
Right? So your genes are all based on a combination of these written in stone blueprints passed to you from your parents. So that's like the only time really in the life cycle of the DNA strands that they get all mixed up is when your parents' DNA mixes together and then makes your DNA, makes your genes.
How do your parents' DNA mix together?
When they love each other very much, a stork comes to the house with a little flask and then mixes it around.
Ew.
Yeah.
Gross.
Yeah, it's from jism, actually.
Ew, please don't ever say that.
It's literally from that, though.
What is jism? Like, what is that word?
Is
it just an old-timey word to refer to semen?
Yeah, I guess.
Is that where jizz comes from?
Or I don't know which direction it goes. I don't know.
You think jism came from jizz?
Maybe.
It didn't.
Well, anyway, that is one half of your DNA comes from that, and the other half comes from your mother's egg.
Your mother's jism.
Essentially, yes. So those all get mixed together when you're a single-celled zygote in your mother's womb, and then that zygote is the single cell that you are based off of because that cell splits, copies its DNA, copies and copies and splits until you have a little baby.
Fucked up.
And that's why all the cells in your body are all the same DNA because they all come from one single cell that got put together from your mother and your father's egg and sperm.
Fucked up.
It's super fucked up. So that's what we call genetic inheritance. Traits get passed on to offspring, And these traits can change and mutate when that happens, but they're pretty much locked from what you got from your parents. But epigenetics is something different.
I've heard that word, but I don't really know what it is.
Epigenetics basically says, in a way, even though you can't change your genes, you can change the way your genes are expressed.
Okay.
So when I spoke to Alex, our friend's sister who is a professional gene researcher, she told me that if genes are the blueprints, then epigenetics is, quote, notes in the margins.
Oh, I love that.
And those notes say things like, build me more, or leave this one alone for a bit. So remember, gene coding, DNA, like the actual genes, is just the blueprints. It's just the instructions for how to build proteins, not where or when or how often. And many things are responsible for determining the when and where and how often, such as your body's chemistry, hormones, the environment, stresses, so on. And basically all of that stuff is considered epigenetics. So here's the first fact to keep in mind. Epigenetics is a very broad term.
Okay.
It can refer to a wide variety of actual biochemical happenings. As long as it's something that affects the expression of a gene, it gets lumped in as epigenetics. Fact number 2 to keep in mind. It's pretty cutting edge science. We're only at the very beginnings of understanding how epigenetics works, and there's a lot of we just don't know that yet. Which, if you're a scientist, is a perfectly comfortable thing to say.
Sure.
But if you aren't, well, we'll get to that. Fact number 3 to keep in mind, it's an exceedingly complex topic. So I said we're at the beginning of our understanding, but even if we were at the end and knew everything there was to know, it's still extremely complex. Genetics is already insanely complex, and epigenetics is just that much harder. Like the amount of dumbing down I had to do just to understand this stuff myself was crazy, even for me, and I'm used to having to dumb things down for myself.
Right. I can concur.
And the reason it's complex is just like, we talked about the very basics of this chemical dance in your cells, but like there's so much more to it than that. There's so many different chemicals that there's more steps than I said in between. There's like so many sub-steps to all the steps that I said and there's sub-steps to those sub-steps.
Right. You didn't talk about the little guy who walks it down the thing.
Yeah, I didn't talk about the little AT-AT walker. Yeah. Well, that only happens when cells are dividing.
Oh, okay.
We didn't talk about cell division.
Gotcha.
Only the transcription part.
Right. Who is that guy though?
I don't remember what he does.
I love him.
Yeah.
He's cute.
Yeah. We didn't talk about a lot of stuff. We didn't talk about telomeres. There's so many things. There's so many aspects of cell biology and chemistry that are working in so many different. I mean, that's why you can make a whole career just on one gene.
Telomeres are what make us age.
Maybe.
It's their frayed ends make us old. You gotta just tighten up them ends. You don't age.
So maybe.
Please tell me you don't talk about that.
I mean, telomeres is a big thing that it does come up. Yes.
It's upsetting.
So it's already. So it's.
I've seen. Sorry, this is totally an aside to you. I've seen telomeres be used as a way to defend misogyny, essentially.
Yeah, telomeres comes. Why do you think that it appears here? Is because it's a thing that pseudoscience weirdos like to. Yeah. So the chemical dance in your cells is incredibly complex. Fact number 4 to keep in mind is something that I mentioned a few minutes ago, which is while your genes are fixed from birth by your parents' sperm and egg, epigenetics is not fixed. Your nurture can't affect your genes' nature, but it can affect how that nature gets expressed, which is powerful.
That does sound very powerful.
Right? Because again, DNA is the blueprints, can't change the blueprints, but you can affect whether the house gets made quickly or slowly or at all.
Right.
Okay, so I said I wanted you to keep 4 things in mind, so let's recap those 4 things. 1, epigenetics is a very broad term and biochemically refers to a shitload of different things. 2, it's still a very young area of research, and there's a lot that we don't know. 3, it's an extremely complex subject matter. And 4, it takes something that was considered fixed, genetic, quote, destiny, and gives it malleability. You are not just your genes, you are how your genes get expressed.
So I have that to worry about now too?
Well, I guess if you want to worry about it, then yes. Why, Kayla, do you think I'm highlighting these 4 factors of epigenetics?
I'm going to take a wild guess here and say that it's because epigenetics is easily misunderstood and therefore
that is a wildly good wild guess.
Evil, or at least Manipulation.
Do all these things taken together sound like nice, ripe, fertile ground for quacks and pseudoscience?
Yes.
Yes. So let's go back to them. Number one, the fact that epigenetics is such a broad term gives plenty of space for ambiguity.
Sure, like quantum physics.
Number two, the fact that it's a young area of research means there are plenty of gods of the gaps for charlatans to fill with whatever truth they are peddling.
Again, like quantum physics.
Mm-hmm. And so gods of the gaps mean for those. So that just means like if it's something we don't understand, then I can provide my own explanation just as a way to just fill that gap of knowledge rather than saying we don't know.
Doesn't it refer to like ancient people's tendencies to kind of like, because there was so little understanding of how the world works, to kind of just like assign like, oh, well, it rained today because the god of rain wanted it to, or things like that.
Yeah, well, so, I mean, broadly speaking, it's like it's an aspect of religion, right? So like god of the gaps basically just means, yeah, to the extent that we invoke deities to explain things we don't know.
Okay.
That's not the only aspect of religion. There's also like spirituality and dealing with the unknown and with, existential and whatever. But the tendency for religion to also explain things that we don't have knowledge for yet is called God of the Gaps.
Gotcha.
And I'm invoking it here because since there's plenty of stuff we don't know yet about epigenetics, there's a lot of room for people to come in and be like, I know what it is. Trust me, it's this. I have the truth.
Right.
So, number three, we talked about it being complex subject matter. So that means that it's difficult to easily and quickly combat falsehood. Or even understand when you're being told something that is false. It's so complex that, like, if somebody says it's this, it's hard for you to be like, wait, no, it's not. That's obviously not that.
Right.
Right? You're more likely to be like, is that how epigenetics works? Okay, I guess. And then number four, the fact that we're removing the quote, the destiny from genetics and placing it seemingly, allegedly, but not quite accurately, squarely in the hands of the individual gives the individual an almost godlike amount of power. And I'm going to call back again, as we said, I'm going to call back here to our Ramtha episode because the Ramtha School of Enlightenment has a tenet that is basically ubiquitous among New Age thought, which is you are your own God.
Right.
And epigenetics, via its opening the door to saying you are not your genes, you have power over them, gives enough room for the irrational to squeeze through that little open door and bestow upon you that godlike you are your own God power.
Interesting. I see that little thread.
And don't you know, the fact that you're your own God and can essentially manipulate reality via thought, it's backed by science. It's epigenetics. It's just science. There's a whole community sprung up around this, which is super interesting, and just how much that smells like the what the bleep quantum flapdoodle.
Right.
You can manipulate reality with your mind. It's just quantum mechanics. It's just science. You can manipulate destiny with your mind. It's just science. It's just epigenetics.
So is this our group for today?
And the end. Okay, so before we go further, I do want to do a quick recap of the science because we dumped a shit ton of information here, and it's not all easy to grok.
Correction, you dumped.
It's our podcast. Yeah, I took an information dump on you. I'm so sorry.
Oh, God.
So
Your mom's going to get mad that you just said that.
Oh, we already said jism, so like...
I'm not putting jism in here.
What? You're not going to put the jism talk?
No.
Oh, all right. Is it just because my mom listens?
No, it's because I don't want people to hear me say the word jism.
Wow. Okay, so we started by shrinking down and going inside a cell and taking a look at the DNA, which is set up at that double helix pattern. The DNA is a blueprint for proteins. So what it does is it'll unwind and unzip and then copy its information over onto that sort of DNA Xerox, which is RNA. RNA is a single strand, by the way. I don't know if we talked about that.
Oh, I don't think we talked about that, but I knew that I remembered that from science.
Yes, because it only copies just like the fact that DNA sort of like locks itself into two strands, whereas RNA
is always open for a good time.
Yeah, exactly. Well, it needs to be because it's taking information from one place and putting it into another place. So then the RNA copies that information from those nucleotides. It zooms on out of the nucleus over to the protein making factory, and then it makes proteins based on the code of the nucleotides that it got from the DNA.
Got it.
And then those proteins all kind of pop out in this big long line of amino acids that then fold up into a particular shape. And one of those shapes may be a hammer, and another one might be a screwdriver.
Got it.
Metaphorical hammer and screwdriver.
Question.
And then we talked about epigenetics. What's your question?
Am I still the size of an Ant-Man?
No. So now you've increased back to normal size, but you forgot to get out of my arm, so my arm exploded.
Oh, cool. All
yeah,
right.
yeah.
That's
so
my dream. That's my
that
dream
was pretty
in
fun.
life.
I'm shrieking and like I'm just like bleeding out over in the corner, and you're just
I mean, your arm like
laughing.
blew clean off. Yeah.
yeah. Oh yeah, yeah. There's no bits of it left.
No.
So yeah, and then we talked about epigenetics, which is the notes in the margins of the DNA blueprints, and epigenetics refers to all of the different ways that genes are regulated and expressed and turned into proteins. So I kind of feel bad because I just read this rant the other day from some random guy on Facebook about how he hates it when podcasts take forever to do their setup before they get to the damn point. And
Then I hope he doesn't listen to ours.
yeah, holy crap, am I guilty of that? And if we have any similar listeners, like, oh man, actually, I guess at this point we wouldn't anymore. They would have just stopped. They would have been like, fuck this shit.
Yeah.
But anyway, here we are. We have finally arrived at our charismatic leader.
Ooh.
One, Dr. Ben Lynch.
He sounds respectable.
So, yeah, this is obviously where we start naming names. But it's kind of hard to not name names.
Are we going to get sued?
We've named names before.
That's true.
Jay-Z Knight. TF Teal's not going to sue us.
We don't know if Teal's not going to sue us. Teal might just not know about us yet.
Well, yeah, I'm sure that both of those parties would sue us if we, meant a damn, if we were big instead of small.
We're big, in my mind.
We have some really, I love our listeners. We just don't have a bajillion of them.
True. Quality, not quantity.
That's right.
That's what my mom taught me.
Not the size, it's how you use it.
I'm going to throw you off of this podcast.
Good luck. So yeah, I don't know. Maybe we'll get sued. Whatever. But anyway, yes, we're talking about a name here because this cult or just weird thing is centered around a person. Now, this group we're talking about, it's less of a like we go to the compound and listen to him talk. Mm-hmm. And it's more of like an online following.
Okay, so like Teal before she had her
compound. Before she, exactly,
okay.
yeah. And it's an online following of like customers and patients. So it's like Teal without as much woo, I guess. I don't know.
Less woo Teal.
Slightly less woo Teal, slightly more other stuff.
Borderline woo is the most dangerous woo.
Well, yeah, actually, you're right about that. But anyway, at the head of this group is Ben Lynch. Interestingly, Mr. Lynch does not have a whole lot of biographical information about him on the web outside of his own website, mthfr.net. In fact, he didn't even have a Wikipedia page about him, which just blew my mind.
Wait, what?
Who
doesn't have a Wikipedia page about them?
Actually, I'm going to check that again. Like, I checked it a couple times, but I'm checking it again.
Like, I'm mentioned on Wikipedia.
Okay, so correction, Ben Lynch does have a Wikipedia page about him.
Got ya.
But it's former professional American football player who played 4 seasons in the NFL for the 49ers.
So this is not the Ben Lynch we're
That's a
talking about today.
completely
Different Ben Lynch.
And there's no like disambiguation that says like, which Ben Lynch you talking about? Like, this is it. That's the only Ben Lynch they have on Wikipedia. So anyway, I don't know why. It weirded me out, to be sure, because yeah, like you said, like I practically have my own Wikipedia page. I guess, we could go make one for him if you wanted.
Does he need our help?
I doubt it. I don't think so. I think he's doing pretty well. But anyway, I thought that was weird. So any biographical stuff that I eventually give you is actually going to come from his own website.
All right.
And after I give you his brief bio, we are going to discuss the type of medicine that he promotes, the specific gene that he's built his brand around. And, oh yes, he has built his brand around a gene.
I mean, it's all about the personal brand these days.
I know, but who builds their brand around a gene? This guy.
Dr. Ben Lynch.
Yeah, he's doing well with it. But I just thought that was curious, right? I'm like, that's just such an interesting thing to build your brand around. It's kind of business smart.
No, that's business savvy because in general, like genes are something that the general population doesn't necessarily understand a lot about. So
although after this episode, hopefully they should understand perfectly.
But just in general, so if you position yourself as an authority on something that people like know a little bit about but not a lot about, so
that's a
savvy
good point.
Business move.
That's actually a very good point, and we'll talk about that a little bit more later.
God,
very good point.
I'm so smart.
Man, you're smart. Jeez, let's just let's just stop doing the podcast. We're just too smart.
Too smart.
It's unbelievable. Anyway, this dovetails into the very next part of the sentence, which is I will tell you a little bit about how he structures his business practices.
God, I feel like we've gotten so business focused the last few episodes, and I love it.
We are. That's just what we are now.
Yep.
Anyway, and then I'll talk a little bit about my own research journey down this rabbit hole and kind of how that threw me off a little bit. And then you and I are going to talk to someone live on the show.
Ooh. Dr. Ben Lynch?
It's not him.
Okay.
I did not reach out to him.
Probably wise.
Yeah. I mean, I watched a lot of his videos, but I didn't reach out to him personally. And then finally, after that, of course, we'll make our call. All of this and more next time on Cult or Just Weird. Sorry, this is the end of the episode.
Well, you're not even going to tell us, like, who Ben Lynch is, like, about him?
This is a cliffhanger, Kayla. If you want to know more about Ben Lynch, you're going to have to listen to our next episode.
Oh, this and more next time.
Yeah, so I'm sorry to tease, but there's a couple reasons why. One is I wanted to do this sort of like setup the way we did with the MLM episode. As we sort of alluded to just a minute ago, it's important to understand how some of this stuff works sort of like at a base level.
Right.
Because otherwise it can get complicated, and it is hard to know who to trust and which things are real and which aren't. So
I mean, we all know
that's why we started this way.
We all know that I have a tendency to join cults before I realize that they're cults. I've done it many times where I'm like, this guy on YouTube knows the answer to everything. 0 and infinity are the same number. And then 2 days later, I read about how he's literally a cult leader. So
there.
So it's wise to do episodes in this fashion.
Yeah. So, and again, like, this is not necessarily to tease or to cliffhang, a little bit to cliffhang, but it's mostly to set it up so that there's this understanding. And so I can drop cool facts like your DNA unraveled would be 12 times the distance to Neptune. So anything else you want to say or ask or whatever before we sign off for this episode of Cult?
I'm going to make a prediction.
Or Just Weird.
I ain't got a good feeling about this Dr. Ben Lynch guy. I think he's up to some hijinks. I think he's up to some tricks.
Shenanigans.
I think he's up to maybe some shenanigans.
He gets into some shenanigans.
That's my guess.
Yeah, there's a little shenaniganery.
All right. Then
which is a word now.
I'm looking forward to hearing more about it.
Absolutely. All right. Well, this is Chris.
This is Kayla.
And this has been
Cult
or Just Weird. Nailed it.